Have you ever wondered about the rules and properties of logarithms? These mathematical tools, with their unique properties, allow us to solve complex equations and understand the world around us in a more profound way. So, fasten your seatbelts, because we're about to dig into the fascinating realm of logarithms. To start, we have the product rule. This rule states that the logarithm of a product, that is, two numbers multiplied together, is equal to the sum of the logarithms of those numbers. In other words, the logarithm of x times y equals the logarithm of x plus the logarithm of y. This rule demonstrates the transformative power of logarithms, turning multiplication into addition. Next up is the quotient rule. This rule is the counterpart to the product rule. It states that the logarithm of a quotient, meaning one number divided by another, equals the logarithm of the numerator minus the logarithm of the denominator. Just as the product rule turns multiplication into addition, the quotient rule transforms division into subtraction. Our third rule is the power rule. This one tells us that the logarithm of a number raised to a certain power equals that power times the logarithm of the number. This rule simplifies complex exponentiation problems into easier multiplication ones. Then we have the change of base formula. It's a handy tool that lets us change the base of a logarithm. The logarithm of a number a with base b equals the logarithm of a with base c divided by the logarithm of b with base c. This formula gives us flexibility when dealing with different logarithmic bases. Now, let's move on to some fundamental properties of logarithms. First, the logarithm of 1 in any base is always 0. This property stems from the fact that any number raised to the power of 0 equals 1. Second, the logarithm of the base itself is always 1. This makes sense because any number raised to the power of 1 is the number itself. Third, the logarithm of the base raised to the power of x is x itself. This property is a natural consequence of the definition of a logarithm. Lastly, the logarithm of the reciprocal of a number is the negative of the logarithm of that number. This property shows the symmetry between a number and its reciprocal in the logarithmic world. So, there you have it, the key rules and properties of logarithms. From the product and quotient rules, to the power rule and change of base formula, to the fundamental properties, these rules shape the way we manipulate and solve logarithmic equations and expressions. They may seem abstract at first glance, but with practice and understanding, they become powerful tools in your mathematical toolbox.